Okay, I want to go to the next section now, section 5.2. And I told you that in this section we would look at our last rule that we're going to cover for exponents. In 5.1, part A and part B, we covered the zero exponent rule. We covered the product rule. We covered the quotient rule. And we covered the negative exponent rule. In section 5.2, part 1 video, our rule number 5, we're going to cover the power rule for exponents. Power for exponents. Power rule for exponents. Okay, let's start out. Let me give you this definition. You write this down, then we'll do a few examples. Okay, write this down. If we have a base raised to a power, and this expression is raised to another power, we will keep the base and multiply the exponents together. Okay. So, let me show you in terms of words. Write this down. So it says, if we have a base raised to a power, and this expression is raised to another power, we will keep the base and we'll multiply the exponents together. I used to refer to this, instead of calling it the power rule, I used to refer to it as the power to power rule, because it gives you a better feeling of what's happening. Something to a power to another power. Power to power rule, we keep the base and multiply the exponents. So let me show you the first example. Now all I want you to do is just write the answer down. So x to the 6 to the third. If you use this rule, you keep the base and you multiply the exponents. So that would just simply be x to what? The 18th. So I want you to write x to the 18th. Go ahead and write that answer down. So this is x 18. Now, let me show it to you a different way, because I just want you to see where the rule comes from. Let me cover this up for just a second. What does it mean to raise something to the third power? That means you say it times itself 3 times. So whatever's under my hand, you're going to say it times itself 3 times. All right, now, what's under my hand? X to the 6. So you're going to do that 3 times. If I do that, that's going to be x to the 6, x to the 6, x to the 6. What's under my hand? 3 times. Now, what does the product rule say in the last section? If we're multiplying and the bases are the same, keep the base, and what do we do to these exponents? You add them, which is 18. Now, what would be the quickest way to go from here to there? Just simply multiply those exponents together. So that's why the rule says what it does. Now be careful. Do not confuse this problem right here with this problem. X to the 6 times x to the third is x to the 9th. There you do add the exponents. All right, so let's do some of these. So what would p to the 8th to the 5th? Power to a power, p to the 40th. But, just to remind you, what would p to the 8th times p to the 5th be? That would not be p to the 40th. That would be p to the 13th. Another one. X. X to the 8th to the 4th is x to the 32nd. But if I have x to the 8th times x to the 4th, that would be x to the 32. I'm sorry, x to the 12th. I looked up at the top. X to the 12th. All right, let's do another one. X to the 4 to the 0. Multiply. 4 times 0, which is 0. But anything raised to the 0 power is 1. But if you do x to the 4th times x to the 0, that's x to the 4 plus 0, which is x to the 4th. So here you add, there you multiply. And if you'll listen to yourself read it, it sounds different. X to the 4th to the 0 and x to the 4th times x to the 0. They both sound completely different. So, all right. Now, this power rule also works for numbers. So if I have 2 to the 2nd to the 3rd, that's 2 to the 6th. But 2 to the 6th is 64. Where does that come from? 2 times 2 times 2, 6 times. Now, it doesn't matter if either one of these exponents is negative. Still works the same way. So x to the negative 5 to the negative 4 is x to the plus 20. Now, let's look at this one. M to the negative 3 to the 5th. That would be m to the negative 15. But remember we said a while ago, you leave negative exponents in your final answer. So this is 1 over m to the 15th. And then one more here. 2 to the 3rd to the negative 1 is 2 to the multiply exponents, negative 3. But we can't leave answers with negative exponents. So when you flip that, that's 1 over 2 to the 3rd. And then 2 to the 3rd is 1 over 8. We will typically, unless it's a really big number, we will typically multiply our numbers all the way out. Okay, now, I want to take the power rule and continue it a little bit. Let me say it first, then I will explain it. So what I did was just showed you how to take something to a power, all in parentheses, to another power. Well, it turns out that the power rule also works. It turns out that the power rule also works for products and quotients as well. Here's what I mean by that. Let's suppose you've got your parentheses and you got an outside power here. Let's suppose you're multiplying, nothing but multiplying in here. As long as you are doing nothing but multiplying in here, you can still use this power rule. Same way if you're dividing in here, the power rule is still in play. But the power rule is not in play when you're adding and subtracting. Let me show you a few examples that you do not have to write down. But I just want to show you this. If I take 2 times 3 and I square it, all right, I'm going to work this 2 different ways. First, let's do what's in parentheses. What is 2 times 3? It's 6. Now, what is 6 squared? It's 36. So the answer to that's 36. Now, watch what happens if I apply the power to each one separately. 2 squared is 4, times 3 squared is 9, and 4 times 9 is 36. Now, let me say again what I said a while ago. If you are multiplying inside of parentheses, and you got a power out here, you can apply this power to these separately. Now, let me show you another one. What is 4 divided by 2? It's 2. Now, what is 2 squared? 4. So the answer to this is 4. But watch what happens if you square them separately. What is 4 squared? 16. What is 2 squared? It's 4. But 4 goes into 16 4 times. So when you're dividing in this parentheses, you can apply this power to both of these separately, if you wanted to. But, let me show you this. It doesn't work if you're adding or subtracting in here. Here's why. What is 3 plus 2? 5. What's 5 squared? 25. So the answer to that's 25. But watch what happens if you square them separately. What is 3 squared? 9. Plus, what is 2 squared? 4. But 9 plus 4 is not 25. It doesn't work. So, you don't have to write this down. If you have A times B and you're going to square it, you can just square each one separately. If you have A divided by B and you're going to square it, you can square each one separately. But if you're adding or subtracting in this parentheses, you cannot apply that power to each one separately. Now, the reason that's important that you at least hear that is a little bit later on down the road, in a couple of sections from now, we're going to work these. But right now, we're going to be doing nothing but multiplying and dividing, so that power rule can be applied to everything in there when we work it. Okay, so let's look at this example right here. So we've got A to the third times B to the fourth to the seventh. First, you can't do anything here. You're multiplying. But you have an outside power. Since you are multiplying, you can apply this outside power to these two terms separately. So you can do B to the fourth to the seventh and A to the third to the seventh. You can do it separately because I'm multiplying right here. So what is B to the fourth to the seventh? Power to a power, we multiply. So this would be B 28. What's A to the third to the seventh? A to the 21st. Now, I can't do anything after that because these bases are different. So that is the answer to the problem. Okay, let's look at another one. Two, A to the negative 3, B4, all to the negative 3 power. Now, whenever you're working these, whenever you've got a parentheses and you got an outside power, you can do them in different orders. You can do all the stuff inside first and then use the outside power. But me personally, on exponents, when I'm dealing with my exponent rules, I always, if I have an outside power outside of parentheses, I deal with that first so that my parentheses are gone. So I usually do the power rule first. Then if I have negative exponents, I move those. And then the rest of the rules you can do, they're easy to do in any order. But I always do the power rule first if it's in play, and then get rid of all my negative exponents. All right, so the power rule is in play here. Can I use it? Yes, because you're multiplying here. Be careful. You're multiplying 3 things here, not 2. So I'm going to apply this power to this, apply this power to this, and yes, this power to the 2. All right, so what do? I multiply this exponent times that exponent. Then this exponent times that exponent, and this exponent times understood 1. All right, when I do that, this is what I get. All right, negative 3 times 4 is negative 12. Negative 3 times negative 3 plus 9. Negative 3 times 1, negative 3. So that's the power rule. Now, get rid of all your negative exponents. This is going to go to the bottom. This one's going to go to the bottom. This one's going to stay where it's at. We did that in the last section. I get that. And then, as I told you a while ago, we always multiply our numbers all the way out. So 2 to the third is simply 2 times 2 times 2, which is 8. So the answer here, a to the 9th over 8b to the 12th. Okay, let's do 2 more examples. Pause it and copy this one down. Okay, you should have this one copied now. You have outside power with parentheses, and you're multiplying and dividing in here. There's no adding and subtracting. So I'm going to apply this power to all 4 of these by multiplying this exponent times that, this exponent times that, this exponent times that, this exponent times understood 1. When I do that, I get this. Let's see, make sure I cut this off any. Okay, so I've got 2 times 3, 6. 2 times negative 2, negative 4. 2 times negative 4, negative 8. 2 times understood 1, 2. Now, everything that has a negative exponent, move it. So I'm going to carry this to the bottom, this one to the top. When I do, I get this. Now, the top, you can put the b first if you want to. Now, I told you a while ago, we always multiply the numbers out. So if you take 5 to the 4th power, that's 625. If you take 2 squared, that's 4. And if you take your calculator and multiply 625 times 4, that will give you the final answer, which is 2,500. Okay, last example. And this will be, this will close out section 5.2. Okay, so pause the video and copy this. Okay, now, pause the video and copy this, and then I'll explain it. Okay, so let me show you where this comes from. Outside power, all multiplying and dividing. Negative 2 times that exponent, negative 10. Negative 2 times that exponent, positive 8. Negative 2 times understood 1, negative 2. Negative 2 times negative 1, positive 2. Negative 2 times 0 is 0. Negative 2 times understood 1, negative 2. C to the 0 is 1, so I don't have to write it. Now I want to move this one to the bottom, this one to the bottom, this one to the top, and I'm not going to move those 2 at all. That I don't have to write anymore because it's 1 in the bottom, which doesn't have to be written. So when I do that, this one goes to the bottom, this one stays where it's at, this one goes to the bottom, this one goes to the top, that goes to 1, and D2 stays in the bottom. And then 3 squared is 9, 5 squared is 25, 5 times 5, A8 in the top, B10, D2 in the bottom. No negative exponents left, and no letter listed more than once. So this concludes section 5.2. There is only one video for section 5.2. Our next section, we will move into section 5.3, and we'll have probably multiple parts to that section.